Good morning, and today this animated mind map is going to show you what a series circuit means. So we'll just write down what we need to know: series circuits. Now if you go to your book, they are on page 461. Page 461. So you can look it up. So what I'm going to do in this animated mind map is I'm going to work through this. I'm going to explain what series means. I'm going to show you a few examples, and that'll be it. So you can work through this mind map with me. And then what I'm going to ask you to do is to do the test yourself questions. Fair enough? So let's start off with, what does series mean? So there are components. There can be resistors, there could be other things, there could be things like bulbs, resistors, anything. Components have the same current. So whatever they are, they have the same current, but the voltage splits. So again, getting back to what do we need to know? We need to know Ohm's law. And we have done Ohm's law on a lot of these elements. So if you haven't done it, you're behind me. So you need to know Ohm's law. And Ohm's law, as far as we're going to say, is V is equal to I times R. We know that Ohm's law states the voltage is directly proportional to the current, provided the temperature remains constant. Right, so we're going to look at a simple circuit. So there is the supply voltage battery. And I have to keep watching about three things at once here. There's an ammeter. And we're coming down to a resistor. Call that R1. Stick another ammeter on it. And I'm going to go down to R2. Here's two resistors in series. And then we'll come back up around to our third ammeter. And remember, an ammeter always makes an ass of itself. Ammeter, small resistance, and in series. Right? See, I have a complete circuit there. Well, in the real world I have virtual, I don't. So I better connect these all up. Right, and there's your ammeter. Right. So let me just undo that there. See, there's a bit of a line has appeared there. Now, where's it gone? There's it there. Ammeter. Right. I better put that bit in as well. Right, so there's your complete circuit. So we're going to show you the conventional current. The conventional current leaves the anode, positive side, comes down through the ammeter. Remember, the ammeter just measures the current, doesn't affect the size of the current because it's got a small resistance. The current then flows through resistor 1, through the next ammeter, then through resistor 2, then up through the next ammeter, and then back round. And then remember, this is a continuous, so that's going to go all the time. There's electrons moving all the time. So whatever current flows through this one will then flow through this one. So I'm going to put a voltmeter. Remember Vince, VPH. Vince is always placed in parallel. Remember Vince's bandy legs. So there's the voltmeter. And there I'm going to call that V1, Vince 1. And here's V2, Vince's brother. He also has bandy legs, must be genetic. So using Ohm's law, I can say that V1 is equal to the current times R1. And I can say that V2, the voltage across 2, is equal to the current times R2. Follow the blue spot. Notice that I and that I are the same. Both currents are the same. Look, components have the same current. The voltage splits. Now, the voltage of the supply, that could be the battery. The voltage of the supply is equal to the voltage 1. There's voltage 1. Add on voltage 2. Now, if you do A level, this comes in under a thing called Kirchhoff's laws, and you'll see it. So what I'm going to do is now replace that I times the resistance total. I'm going to see what I could scrap all that above and replace with one resistor. So They all have the same current. Oh, this is where we'll splash out. The current splits. I'm using a red pen. Wow. So now we're going to go to R total is equal to R1 plus R2. So that's the rule. When they are in series, you simply add them. Right? Well, blank page. When they are in series, you simply add the two resistors. How does the examiner make this tricky? Well, might make that 1 kilo ohm and that 10 ohms. Fair enough. So that's how they can make them nasty. So just check that when you're doing it. So, let's see, can I do a question? Yes, I'll just go down here and do a question. Go back to black. So, let's have a look at a question. Here's two resistors. Just make this up as we go along. Nothing new there. So there's one resistor of size 50 ohms and 6 ohms. So I could scrap that and have one resistor of size 56 ohms. Fair enough? Because R total is equal to R1 plus R2. So 50 plus 6 is 56. Fair enough? Now I'll do a bit of a nasty one down here. I've never seen one of these asked at GCSE, but again, there's no reason I couldn't, because to me this is just a question, do you know your stuff or not? So here we have 4 resistors in series, and how do I know that they're in series? Well, whatever current goes through the first one, follow the blue spot, whatever current goes through that one, goes through that one, goes through that one, goes through that one, so they're in series. The same current, and the voltage is split. Now, see the way I have that 1 kilo ohm? Oh, that was nasty. That's the same as 1,000 ohms. That'll be a nasty trick. So what's the R total here? R1 plus R2 plus R3 plus R4. That's what your R total is equal to. So that was 1,000. Put them all into the same unit. Plus 100. Plus 10. Plus 1. So that gives me 1,111 ohms. Fair enough? Now, I want to go up here and look at another. Sometimes you have to break these questions down. So I'm going to make up a question here. There's like a car battery, 12 volt car battery, unless it's a classic, like a VW, they were 6 volt. Lord knows why. VW obviously does. So there's an 8 ohm resistor. I have to keep checking the screen here because in my world it's all grand. Right? So there's a 12 volt power supply in series, because look, the current comes, follow the blue spot, the current comes there, please blue spot move, current comes there, down through the ammeter, doesn't affect the current, ISS, ammeter small resistance, and in series, current flows through there, on round, back up, complete circuit. Do you see that? Last but it wouldn't do, come on you brute. Right, it's coming down there, yes, complete circuit. So what can I scrap that with? I could scrap that and redraw this. That's 8 and 4 is 12. So I could have this. This is the same thing. There's my 12 volt supply. And I can scrap these two byes for one 12 ohm resistor. Fair enough? Now, what's the current flowing? Can we find the current leaving this battery here? There's conventional current. Remember the tooth fairy and Santa? Don't get too upset. V equals I times R. So I is equal to V over R is 12 over 12 is 1 ampere. So 1 ampere flows in that. This is the same as this. So that ammeter, I'm going to change to red here. That ammeter will be reading 1 amp. Ah, yeah, brute. 1 amp, yes. Now, follow the blue spot again. What voltage would be across that? Well, I know that there's 1 amp comes through this. And I know it's 8 ohms. So V equals I times R. So there must be 8 volts across that. 1 amp flows through that. 4 ohms V equals IR, so there's 4 volts across that. And 8 volts and 4 volts gives me 12 volts. Fair enough? Now, let's go and see, can we do another type of question here? Just following it over at the page. Again, this will all be up online for you. I'm going to have a 24 volt battery. Where would you get a 24 volt battery? Yes, all the Massey Ferguson men are now roaring fools. It's in a tractor. Right? Some lorries also have 24 volts. So, just trying to complete this circuit. I'm making the question up as I go along. I know that's a 9 ohm resistor. What's that if 2 amperes flows? And if I draw in 2 ammeters, see that red one? Right. So, follow the circuit round. Current comes out, oops. Current comes out. Current comes out, down 2 amps, so 2 amps flows through that. 2 amps, yes. Same current, so that's going to read 2 amps. And that's going to read 2 amps. So that's the same as, there's the same thing as a 24 volt supply, and I know there's a 2 amps conventional current, doesn't exist, but write down anyway. I know that I can replace those resistors of 9 plus some number. Yes? What's the sum number? Well, let's have a look. V equals IR. Put it in a bracket. Every mark's a valuable mark. R equals V over I. 24 over 2. 12 ohms. So there's 12 ohms. So I know that that resistance in total is 12 ohms. So 9 plus something is equal to 12 ohms. So the something must be 3 ohms. So that's series done. So let's go back up to the top. Series means page 461 in your book. The components have the same current and the voltage splits. That's what series means. Not one after each other. That is not right. The components have the same current flows through them. And I mean the same current. That has to be the current. The same current. And the voltage splits. So there's series done for you. You have a wee look at that, and then later on you're going to have to do the other one. Thanks very much for listening. Bye.